Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this is the last of all questions of paper 9709/42 for the session October November 24. Let's read the question. It says two particles A and B of masses zero point 0.2 kg and zero point 0.3 kg respectively are attached to the ends of a light inextensible string. The string passes over a small fixed smooth pulley which is attached to the bottom of the rough plane inclined at an angle theta to the horizontal, where sine theta is equal to zero point 0.6. Particle A lies on the plane and particle B hangs vertically below the pulley 0.25 meter above horizontal ground. The string between A and the pulley is parallel to the line of greatest slope of the plane. The coefficient of friction between A and the plane is 1.125. Particle A is released from rest. Find the tension in the string and the magnitude of the acceleration of the particles. So as there are two different values are supposed to be obtained, we'll have to form two equations using each one of these two particles. Well, first of all, we will have to pick up the concept. What is the concept we are going to apply to solve such question? We know that concept of the motion law of Newton is applicable for solving such question. Well, for Con- applying the concept of the motion law, we know first of all we'll have to find the normal reaction force, because the plane is not smooth at all. Look at this. It is written that the coefficient of friction between A and the plane is 1.125. That means the surface is not smooth at all. So first of all, we'll have to find the normal reaction, and before that I can complete drawing the diagram. This is the particle, okay? So from here, this is normal reaction and weight is acting over here, and then here is our angle. How much is the angle? Angle is theta. This is theta. Well, after that, it's a right angle triangle now. Well, so let us find R, normal reaction. First of all, R is equal to R plus, as there is no upward force, so it is nothing but 0. Then downward force is this one along this one. So in terms of this triangle, this is actually horizontal axis, x-axis. So we know x-axis or horizontal axis is equal to mg, means weight cos theta. Well, now we will have to find how much is the value of cos theta. About the theta, they have written sine theta is equal to 0.6. So sine theta is 0.6, means not over here. Let me draw over here. Sine theta is, this is theta. They have written that sine theta is zero point 0.6, means this is 6 and hypotenuse is 10. So surely the horizontal axis is going to be 8. Well, then cos theta means, so sine theta is equal to sine theta equal to zero point 0.6, means cos theta is going to be 0.8. If we divide 8 by 10, it is going to be 0.8. Well, so let us find our normal reaction. R is equal to mass of the particle. We are talking about particle A. Look at this. Particle Q is not at all on any plane. It is just hanging below particle A. So there is no surface attached to B. So there should be no question about normal reaction to or frictional force about B. It's all about A. So mass of particle A is 0.2 0.2 and acceleration due to gravity is 10. Let me zoom it out. So r is equal to zero point 0.2. Well, it's 0.2, 0.2 and acceleration due to gravity is 10. 0.2 into 10, and our cos theta we have already found, it is 0.8. 0.8. So if we multiply all of this quantity, our normal reaction is going to be 0.2, that is 2, and 0.8, it is 1.6. So 1.6 is our normal reaction force. Okay, our normal reaction force is 1.6 Newton. Well, then we are going to apply the concept. Already we have decided that the concept we are going to apply is the concept of the motion law of Newton. And for particle A, we will start with particle A. Okay. For particle A. For particle A. Particle A, if we look at the direction of particle A, it is just sliding down. Okay. So the direction is this way. And the concept we are going to apply is the driving force minus resistance force is equal to mass into acceleration. Well, let us see what is the driving force for particle A. If we look at the figure, we will see, look at this, A is being pulled down by particle B. That means the tension in between AB is the driving force for particle A. So tension is the first driving force. And let us see whether any other force which is causing slide the particle A downward. So the another driving force is weight. Weight is also trying to move trying to slide the particle down. So 10 weight is, this is the force we are going to find. This is parallel to the horizontal, I mean parallel to the plane. So for the, in term of this triangle, this is nothing but the vertical line. So for vertical axis, our formula is mg sine theta. Then there is no more force acting as driving force. Now resistance force we know, for frictional force is mu r equal to mass into acceleration. The mass of the particle A is 0.2 and acceleration. Well, if we simplify this, it is going to be one after the other. We will keep on writing them. Well, tension is to be obtained, so let it remain unchanged. And mass of particle A is 0.2 and acceleration due to gravity is 10. Sine theta is given 0.6. Already we have seen that sine theta is equal to 0.6. So it is going to be 0.6 minus mu is the frictional coefficient, which has been given as 1.125. So 1.125, let me erase this, minus 1.125, and it will be multiplied by the normal reaction. Normal reaction has already been obtained, we have got it, nothing but 1.6. 1.6 our is our normal reaction force. So it's 1.6. 1.6 equal to, right side is nothing but 0.28. So if we isolate our A acceleration, it is going to be A is equal to tension is to remain unchanged plus, if we multiply all of this 20 and 6, 0.62 and zero point 0.6, it is 1.2, 1.2. So let us write directly, it is 1.2, and the negative one is, if we multiply 1.125 by 1.6, it is going to be 1.8. So 1.8 minus, that means 1.8 minus 0.12, I mean 1.2, it is going to be minus zero point 0.6, minus zero point 0.6 over zero point 2. So this is our equation number 1. We may leave this as equation number 1, and initially we have realized that there will be two equations because we are going to find two simultaneous values. That's why we'll have to form two simultaneous equations. Well, for particle A we have completed so long. Now for particle B, for particle B, the next equation will be formed of particle B. For particle B, and B is just hanging downwards, so it is vertically downward, direction is vertically down, perpendicular vertically downward. So the concept is the same concept, driving force minus resistance force is equal to mass into acceleration. And if we observe the particle B, it is, look at this, for B driving force is nothing but the weight, only weight is, it is being pulled down by none but weight. So for weight we have calculated already, weight is mg sine theta. So please don't get confused that here theta, that theta was applicable for particle A. Look at this, this theta is applicable for particle A, this is not for particle B. Here theta will be 90 degree because this is vertically downward. Okay, so this is driving force. And what is the resistance force for particle B? There is nothing which is pulling it backward or causing resistance to motion except the tension, tension in the string. So this is the resistance to motion, to motion of particle A. Okay, so tension is the only resistance to motion of particle B. So this is tension, and right side is going to be mass of the particle A. B is 0.3, acceleration is A. If we isolate our A, mg, mass of the particle A is 3, acceleration due to gravity is 10, and sine theta is, actually it's sine 90 degree. Okay, so sine 90 means 1, you can write here 1, minus t is equal to 0.3a. If we make a as subject, it is going to be a is equal to, there will be a fraction, and 0.310, it is 3, so 3 minus t over zero point 0.3, and we may leave this as equation number 2. So solving the equations simultaneously, we will be able to find both the values. So let me write just beside this, let me see how much space do I have. Yes, I can write just beside this. Okay, so if we write from from equation 1 and 2, 1 and 2, in both the equations, look at this, the left side is our acceleration. Look, in equation number, it was equation number 1, sorry, it should be equation number 1, not 2. It is equation number 1 and this is 2. If we observe both the equation, look at this, the left side of each of the equation is acceleration, so right side must be equal. So first right side is t minus 0.6 over 2, t minus zero point 0.6 t minus t minus zero point 0.6 over zero point 0.2 equal to the other equation is 3 minus t over zero point 0.3. 3 minus t over zero point 0.3. So if we do cross multiplication, it is going to be 0.6 minus 0.2t equal to 0.3t, 0.3t, then minus 0.18, 0.18. After that, if we add up both the t's, it is going to be 0.5t, sorry, negative 5t, point negative 0.5t, negative 0.5t equal to, the right side is also going to be negative 18 and 6, so it is 0.78, 0.78. Hence our tension is going to be, hence our tension is going to be 0.78, 0.78 over zero point 0.5. Well, so finally, sorry, 0.78 over zero point 0.5, let us use our calculator. 0.78 over tension in the string is 1.56 Newton, 1.56 Newton, and this is one of the answer. Okay, one of the answers. We should not forget that they have told us to find the acceleration as well. Okay, so let us find acceleration. Substituting the value of tension in any of the equation, we may find the acceleration. Hence our acceleration, hence a is equal to what? Let us choose the simple one. 3 minus tension, 3 minus tension is 1.5, 1.56 over zero point 0.3, 0.3, 0.3. Hence our acceleration is going to be 3 minus 0.1, 1.56, 3 minus 3 minus 4.8 meter per second square, and that is the second value we should find. So this is how we can solve it very simply. So first of all, I would like to say that there is nothing complicated. This is one of the most common questions in mechanics one, that if the particles are connected with string, then in between them there is a tension, a force of tension which acts in between them. So tension, once tension is driving force, whereas tension is the resistance force for the other one. And as the plane is not smooth at all, so first of all you will have to find out the normal reaction. Well, let us see what the next questions say. The next question is, it says, what does it say? It says, when B reaches the ground, it comes to rest. Find the total distance that A travels down the plane from when it is released until it comes to rest. You may assume that A doesn't reach the pulley. So it's all about, look at this, distance and velocity concept. So for distance and velocity concept, first of all we will have to find the velocity when B reaches the ground. Okay, we will have to write, yes, we will first of all we will have to find the velocity of A when B reaches ground. Velocity of A, velocity of A when B reaches the ground. B reaches the ground. Okay. Actually, velocity of A and B are same. So instead of B, I have written A because now everything is based on question A. That's why I have mentioned A. But velocity of A and B must be same because both of them were accelerating at same rate. Well, so velocity is equal to, v square. We are going to apply the concept of velocity and displacement concept, which is v square is equal to u square plus 2as. Let me zoom it out more. Yes. So velocity is equal to velocity v square. We know that v square is equal to v square equal to u square plus 2as. Okay. So velocity, final velocity is, okay, a final velocity is to be obtained, isn't it? Let me clarify this from the diagram. Look at this. This is what the diagram is. The concept is when B is reaching the ground. Look at this. When B reaches here, when B reaches the ground, A was still continuing moving downward. Look, after reaching the ground, when B reaches the ground, then there is no tension force acting in between A and B. The string was no more tight. Initially it was tight and inextensible, but when B reaches the ground, it was no more tight, it was slacked. Okay, now the concept we are holding is that B might reach the ground, but A was still moving downward for little time, for a little moment. So we will have to see, suppose here A was over here. A was over here when B reaches the ground. But after that also it continued moving downward. So at this point we will find the velocity of A. Okay, that means the final velocity of A when B reaches the ground. And acceleration is, we have, it is about acceleration and of distance velocity acceleration concept. So acceleration was 4.8. Okay, so let us apply this value. When B reaches ground, A was still moving downward. Okay, let us see when B reaches ground what was the initial velocity of A. For B, its B has already stopped, but A was still moving downward. So let us find the initial velocity of A. Okay, initial velocity of A is final velocity of B when B reaches the ground. So please don't get confused. It is V is equal to initial velocity when the particle was released, it was 0. Okay, so 0 square plus 2 acceleration when the particle was moving downward was 4.8, isn't it? We have already found it was 4.8 meter per second square. So 4.8, and each of the particle traveled 2.25, sorry, 0.25 meters. They each of the particle travel 0.25 meter. If you wish, I can draw the figure over here. Or let us continue. I don't find it complicated to understand. Hence, velocity of particle A when B touches the ground, B is at rest. Okay. So it is going to be square root over, if we multiply 2 into 4.8 into 0.25, it is going to be 2.4. It is 2.4. 2.4 is the initial velocity. Okay. Now we will have to find the acceleration also, because we are going to apply the concept of acceleration, velocity and displacement. Displacement is to be obtained and acceleration and velocity can easily be obtained by us. So we will write when acceleration of acceleration of, or we can write for a acceleration of particle A, acceleration, let us write for acceleration of, for acceleration of particle A, particle A when B reaches the ground, particle A when B touches the ground, when B reaches the ground, reaches the ground. Look, B reaches the ground and it stopped, but A was still moving downward. This is the concept actually. That's why we are going to apply the concept of the motion law of Newton. The same concept, B was still moving downward. Okay, sorry, A was still moving downward, and the concept is driving force minus resistance force of equal to mass into acceleration. Okay, so driving force. Now let us analyze the question. Look at this. B when B reaches the ground, when B is at the ground, A was still continuing. Okay, so what is the driving force for A? Look at this. A was still moving down. A was still moving down. Okay, from this point. From this point, A was still moving down, but as B has touched the ground, there is no tension in the string. String has already been slacked. It's no more tight and inextensible. It is slacked. As there is no tension acting in the string, so only driving force is the weight. For A, look at this, B has already touched ground, so please don't get deviated from the main concept. B has touched the ground, so there is no more tension acting in the string. String has no tension at all. Only weight is trying to move the particle A downward. So the force is actually, tension will go away. Look at this. For particle A, we have written here, it is tension plus weight, both of them have been supposed to be the driving force. Now as there is no tension, only the weight is causing the particle A slide down. So mg sin theta and minus mu r is our, mg sin theta is the driving force and mu r is our frictional force. So it is mg sin theta. Okay, let us write mg sin theta, sin theta minus frictional forces mu r, still there is frictional force, and mass of particle A was 0.2, acceleration is A because we are trying to find acceleration. Okay, m was 0.2 into acceleration due to gravity is 10 and sin theta is 0.6 minus mu, the frictional coefficient was 1.125, and r, we have already obtained r was 1.8 or 1.6, 1.6. R was 1.6. So it is 1.6. 1.6 equal to right side is 0.2a. We are to find acceleration. Let us multiply. It is 2 and 0.6. It is 1.2 minus, if we multiply 1.6 and this is, it is going to be 1.8 equal to 0.2a. So acceleration is going to be, let us write here the hence symbol because it may be the last of all step for acceleration. So acceleration is negative 6, negative zero point 0.6, negative zero point 0.6 over zero point 0.2 means it is nothing but 3 meter per second. So this is the acceleration when B reaches the ground, but A was still moving downward. Okay, now we will apply, we have got the velocity. Look at, so let us write for velocity of, or for displacement of A when B reaches the ground. Okay, for displacement of A, for for displacement of A, displacement of A when B reaches the ground, when, after, sorry, not when, it is after B reaches the ground, after B reaches the ground. Okay, so when B reaches the ground, A was still moving downward, and the concept we are going to apply is V square is equal to U square plus 2AS. Okay, so final velocity of A was definitely 0. Let us see. The question told that find the total distance that A travels down the plane from when it is released until it comes to rest. So at one stage A is also at rest. So final velocity is 0. When A is at rest, final velocity is 0. So 0 is equal to initial velocity. We have already obtained initial velocity was 0.24, square root over 0.24. So 0.24 square and minus, why are we using minus? Because it was negative. Let me erase this. It is no more positive, this is also negative. Okay, it will be negative acceleration, I means deceleration. So equal to minus 3 meter per second. Minus 3 meter per second square was the acceleration, I mean deceleration, when B reaches the ground. Well, so it is negative 2 acceleration due to gravity, I mean acceleration we have already got is 3, and S is to be obtained. Okay, so finally it is going to be, if square and square root resolve each other, it is 2.4. So negative 2.4 is equal to negative 6s. Okay, hence our s is going to be 2.4 divided by 6, it is 0.4. 0.4. So this is the displacement after B reaches the ground. But they have told us to find the total distance traveled by A from from down from the plane when it is released until it comes to rest. So first, when A was released, to look at this, each of the particle traveled this distance, this 0.25, this 0.25 distance, suppose this is until here, it is 0.25, it may be 0.25, 0.25 was the distance, because each of the particle traveled the same distance when B reaches the ground, because this was 0.25. Look at this. If B traveled 0.25, A was definitely traveling 0.25 meter as distance. So when before B reaches the ground, the 0.25 meter was traveled by everyone, and after B reaches the ground, only A traveled zero point 0.4 meter distance. So now total distance is zero point 0.4 plus 0.25 meter. So let us write total distance. Hence we can write total distance is equal to, or using the same ink, total distance. Okay. So total distance is equal to hence total distance traveled by a total distance is equal to, first of all, each one of them traveled 0.25 meters, and later on only A traveled zero point 0.4 meter, 0.4 meter. So finally A traveled total 0.65 meter as travel distance. So this is what the total distance traveled by A, and this is the whole of the solution at a glance. Let me show the first part. This is the first part of the solution, and second part, once again, this is the second part. That means the distance traveled by A since the beginning is 0.65. 0.25 was traveled by each of them initially, and after B reaches the ground, A continued to travel zero point 0.4 meter distance. So total 0.65 meter was traveled by A. So thank you all for being with me. May Allah bless us all with beneficial knowledge. Fi amanillah.